with the code 0625, we have to start the basics of magnetism. So starting of the basic of magnetism, first you have any idea about the magnets, and then you told me that the magnets anything that attract or repel each other because of the same or the like charges, same or the like poles. In the magnets we don't discuss about the charges, we just do discuss, but the basic concept is like about the poles. Okay, so the magnetism is a fundamental force of nature that occurs due to the motion of electric charges. It is one of the key forces along with the electricity that governs many of the physical phenomena in the universe. Okay, this is a basic definition of magnetism. Magnetism is called the force of attraction and repulsion between the poles of the magnets. Okay, because of the field lines, because of the electric field lines, because of the magnetic field lines. Okay, can you write the definition? You have to mention, you have to set your page, then you have to write the definition of magnetism. Okay, magnetism is a fundamental force of nature that occurs due to the motion of electric charges. It is one of the key force along with electricity that governs many of the governs many of the physical phenomena in the universe. Yes, so look, start from this PDF. Forces are the strongest at north and the south pole because these two are the opposite charges. Maybe the charges is coming from the north and going towards the south. Okay, so the same poles will repel each other and the unlike poles will attract each other. So the unlike poles attract, like poles repel. So north and south going to attract each other, south and south repel, and the north and north as well repel. So what are the magnetic materials? Magnetic material will always be attracted to a magnet and can be magnetized. So this is a concept of a magnetized. When there is a charges, when there are two opposite magnetic poles, opposite, one is north, one is south, they are attracted by each other. When the force of attraction, they are switching their charges, they are transferring their charges from one place to another, so that magnet become magnetized. Okay, did you get the concept? So they contain iron, nickel or cobalt. Hard magnetic materials, steel, difficult to magnetize. These are the specific materials which do not get magnetized easily, difficult to magnetize, do not lose their magnetism, and used for permanent magnets. And first priority of them, they did not get magnetized easily when they get, and that is a very difficult step to demagnetize them. Okay, and they use as for the permanent magnets. This is the best example of the permanent magnets. And magnetic materials, I hope you get the concept of magnetic materials. Okay, magnetic materials are the substances that exhibit magnetic properties when exposed to a magnetic field. When they bring around to the magnetic field, they show a magnetic properties. And what are the magnetic properties? They will attract or repel. Okay, and their behavior is primarily influenced by their atomic structure and the arrangement of their electrons. Magnetic materials are generally, do you have this topic is included or not? The classification of magnetic materials: ferro, para, and last one is dia. No? Okay. So the next thing is, so we have the soft magnetic materials. The best example is iron. Easy to magnetize, easy to lose magnetism, and their magnetism is only temporary. So this is the difference between the two type of magnets: permanent magnets and temporary magnets. Permanent magnets that did not get easily magnetized. When they don't lose their magnetism very easily, and when they are known as permanent magnets, and there are specific magnets which are easy to magnetize. When they can lose their magnetism easily as well. Okay, so any examples of permanent and temporary magnets? Okay, and we have other magnets also known as cobalt, neodymium magnets, alnico magnets, ferrite magnets, bonded, and so on. Okay, and the temporary magnets are soft, iron, steel, electromagnets, magnetic shields, magnetic tools. Okay, so many examples. So we get the idea of magnetic materials. Now what do you think about the non-magnetic materials? Not attracted or repelled. The magnets that are repelled by each other, they are known as non-magnetic materials. The magnet that are attracted, magnetic; that not attracted, non-magnetic. Okay. So non-magnetic materials. Non-attracted or repelled by magnets cannot be magnetized. All metals that do not contain iron, nickel, or cobalt, all non-metals. So the other example, the metal that do not have iron, nickel, and cobalt, these are the best example. Any substance, any element, any metal that do not have iron, nickel, and cobalt inside it, that will not be magnetized. That is the best example of non-magnetic material. So to determine whether a material is a magnetic material or non-magnetic material, bring it close to the known as a magnet. For example, these are three magnets. Okay, A, B, and C, D. Repel magnet, only attract magnetic material, not affected non-magnetic material. Okay, just let's solve this practical. So the next picture is like with the practical. Yes. There is A, B, and C, D. Look here, A, B, C, D, and E, F. Now first one is attracted, that is a magnetic material. Okay, the A and B pole is attracted by the north. That A must be the south pole, na? That's why it attracted. Okay, and then in the next picture, this is the same attraction. Now B is also attracted by the north. B is also attracted by the north because that is the whole magnet that is south. That is the south pole. So it is attracted by both to the north pole. Okay. Yes, because this is a two magnets like north and south. This is only this part. Only this part. When I place here and there, then it will be attracted by both of them. Whole part, na? Whole part. And the next, no, this is a magnetic material. Look here. Look, this one is only attracted. Magnetic material. Now I will move to the C, D, N part. Look in this picture. This is in this position. And in the previous position, this is like this. Do you think it moves slightly from its original position? It does. Yes, for example, this is in this position. When I brought a magnet near to it, it just changes position. What do you think? Attracted or repel? This is attraction or repulsion? This is this is a repulsion because they are repelling each other. They are repelling each other. This is a magnet. Look, they repel each other. This is like going away from that north pole. Okay, so this is a magnet. Got it? When I have the other magnet E and F, when I brought north pole to that, it does not show any action. It does not neither attract it or neither repel. So that is not affected. This is a non-magnetic material. This is a non-magnetic material. Got it? Non-magnetic material like lack of magnetic moments, no magnetic responses, stable characteristic. That's why we call that magnet as a non-magnetic material. Okay, so what are the examples of non-magnetic? Wood, plastic, glass, rubber, copper, aluminium, leather. Yes, we have so many examples. Okay. Now the properties of the magnets, and this is the same picture. Look here, this is the north and the south pole. North and the south pole. Magnetizing the magnetic materials. Induced magnetism of magnetic materials by a strongly magnetized is usually weak. So we have to get the idea of magnetizing magnetic materials. Involves including a magnetic field within them to align their internal magnetic domains. This process can transform a non-magnetized material into a magnetized material one. For example, if we have any magnet that is not magnetized, that is a non-magnetized. When we place that non-magnetized material inside the magnetic field, that will become a magnetized material because of the flow of the charges inside it. Okay. So look here, this is a magnetization is a process of inducing magnetism in a magnetic material. These are two materials, iron loses magnetism, iron, and this is a steel with the north and the south pole. Okay. And after this, they have this concept like using direct. We have a 2 to 3 process: direct magnetization and electromagnetic induction, hammering or striking, heating or cooling. I think this is a direct current. They use then direct current. And then next example is stroking. I just gave you the hammering. This is again the same example. This is like the another example. This is another example. So okay, these are the basic steps in which we can magnetize the metal that is non-magnetized. Okay, so let's just using a direct method. Stroking is a steel with a magnet. Magnetism is usually strong. For example, you have a magnet that is demagnetized. When you stroke or hit or hammer that magnet with another magnet, the charges will start flowing from one to another. So that demagnetized magnet will become magnetized. Okay, charges will transfer now. Hammering and striking is a process. Mechanical shock or vibration is applied to the materials while they are in magnetic field. Okay. And the concept of direct current. In the direct magnetization, the material is placed in a strong external magnetic field such as that produced by the magnet or electromagnet. For example, the most effective way to magnetize a magnetic materials, a steel nail is inserted. For example, this is a circuit. This is an circuit. So that circuit has a loops. Okay. We can a long coil of wire. That is a coil. What is that? Coil. Okay. So in that coil, when we place a nail, a steel long nail, steel nail, that nail is demagnetized. That nail does not have any magnetism inside it. When I place it inside the coil in which current is flowing, switch is on, source is provided, that steel iron will become magnetized. So when you touch it, you will feel a little current or shock, is it? Yes. So it's mean that steel iron will that steel nail become Magnetize. Very good. So DC power supply is turned on. Direct current is direct. There is no alternating process. The current is direct for body to that steel. There is not a middle way. Okay. So pass a large DC current through the coil. So the current generates a magnetic field and that magnetizes the steel ring. For example, this is an equipment that is non-magnetized. Okay. So there is a coil of a magnetic field that will cover that nail and provide the magnetism power to that demagnetized object. Okay. For example, if we rub this, if this is a magnetized, this is demagnetized, and by rubbing that demagnetized pole will also become magnetized. Okay. And I hope you get the concept of magnetizing, demagnetizing, or only magnetizing, sorry. How we can magnetize any metal. Okay. What is the process of demagnetizing the magnets? Okay, before doing this, we have to write the few heading points, okay, of magnetizing material. Okay, start writing it. Now, let me know when you're ready. I will speak and you have to write, okay? Now, what are the methods that we can magnetize a material that is demagnetized? Okay. Demagnetized. Can I start? Okay, the first heading will be heating. The question is, we have to write the question. What are the methods to magnetize the material that is not magnetic material? Yes, how to magnetize the material? So the first is direct magnetization. Direct magnetization or using direct current. You can use both names, okay? Yes, direct magnetization or using direct current. And then second method will be electromagnetic induction. That is the process. That is the electromagnetic induction. This one. And then hammering or striking. Hammering or striking. And I think that will be the enough, okay? Now the demagnetizing magnets. Demagnetizing magnets. So demagnetizing is a process that destroys the magnetism of a magnet. So for example, the magnet is magnetized. You just remove the power of that magnet and that magnet become useless. Demagnetizing the magnets, and what are the methods and the examples. So we have to get through these three topics, like the magnets, examples, and then methods, okay? So demagnetizing a magnet involves reducing or completely eliminating its magnetic properties. What? Its magnetic properties. So this can be useful in various applications. We can discuss like such as resetting the tools, preventing magnetic interferences, restoring the materials to their original non-magnetic state. For example, if you want any material into its original state, for example, you nail the nail. Okay, right now we magnetize the nail, na? We can demagnetize that nail as well, but just removing the properties. And how we can remove the properties? These are very easy methods. Okay. So methods basically are heating mechanism, mechanical shock, an alternating magnetic field, using demagnetic tools, and so many other examples as well. So it's a process that destroys the magnetism of a magnet. Demagnetization by heating. To place magnetic along with the west east of earth. For example, this is an earth. You place south and then east. Is it south and east, na? West and east. Sorry, west and east. So demagnetization by heating. You can remove the demagnetization. You can remove the magnetism of any element by hitting that. To hit a magnet by a hammer. Okay. And the next thing is to hit a magnet by a hammer. And we can do this. Demagnetism by hitting, to hit a magnet by a hammer with a moderate amount of force until it demagnetizes. So you don't have to put all of your force. This is a specific sequence in which you have to apply your force, not more than in a specific amount. Okay, did you get the point? Yes. And then next thing is and here is another example, demagnetization by alternating current. To insert a magnet into a long coil, turn on the AC power supply, slowly pull the magnet away from the coil until it's completely, it is on the next page, completely outside the coil. To large alternating current generates the changing magnetic field to the demagnetize the magnet. For example, this is another method in which you have to insert a magnet into the long coil. This is a magnet in the long coil. You are applying the AC power supply. Slowly pull the magnet away from the coil. You are placing that coil away into that coil that you place inside the coil. Magnet that is placed inside the coil. It has another magnet that is outside the coil. Okay. The large alternating current generates the changing magnetic field to the demagnetize. For example, this one is getting the magnetism from this current, and you have placed another magnet here. That will give all of its magnetism power to this, and this will become magnetized, demagnetized. Okay. I am just finishing this lecture in which we learn about the magnetizing, demagnetizing. So if we are going to study about the magnetism of anything, that we have to learn about the magnetic field of the magnets. So the magnetic field is a region in space where magnetic material experience a force. So if we are going to discuss about the poles, north and the south pole, that north and south poles are generating a magnetic field lines towards or away. So we can see that the north become a positive. North is just the best example of positive charge, and the south is the best example of negative charge. Okay. Magnetic field lines, these are the very important points, Ayan. These are very important points. Lines run from the north to west poles. Lines cannot cross each other. Remember, they can join with each other, they can meet with each other, but they cannot cross each other. And strong magnetic field strength where lines are close each other. If they are afar, they have a very weak strength, and they have a near, they have a very strong. And the arrow is indicating the direction of force acting on the north pole of a magnet. Okay. So the magnetic field of a bar magnet. This is the best example of magnetic field of a bar magnet. Okay. I just want you to, after the class, I will give an example. You have to draw the bar magnet and you have to draw the field lines as well on a white sheet paper. Yes? क्योंकि जब हम किसी नॉर्थ एंड साउथ पोल को पास लेके आते हैं ना, तो उसके अंदर फोर्स ऑफ अट्रैक्शन क्या होती है, ज़्यादा होती जाती है ना. वो जो छोटे होते हैं, 2 टॉयज़ होते हैं, वो मैग्नेट वाले अक्सर आते हैं ना, वो ओवल शेप में. अगर आप उसको एक दूसरे से दूर करते हो तो उसकी फोर्स क्या होती जाती है, कम होती जाती है. अगर आप उसको थोड़ा पास लेके तो कितनी फोर्स एक दूसरे को अट्रैक्ट करना शुरू कर देते हैं, अट्रैक्ट करते हैं ना. तो इसी तरीके से व्हेन यू लाइक put closer to opposite poles, they will attract each other with a strong force and they have a very strong strength of field lines. When they are far away, they have weak force, they have weak strength of field lines. ये concept है, ठीक है. Okay, what is the overlapping of magnetic field lines? When they are similar, they will repel each other. When they are unlike, yes. तो ओवरलैप कब करती हैं, अनलाइक चार्जेस. वेरी गुड. अब ये देखिए यूनिफॉर्म मैग्नेटिक फील्ड कब होती है. लाइंस रन फ्रॉम नॉर्थ टू साउथ पोल्स, लाइंस आर पैरेलल एंड सेम. अब देखिए उसकी कहीं पे भी आगे पीछे से नहीं निकल रही है. लाइक दे आर मैचिंग विद ईच अदर विद फेजेस. फर्स्ट फेस ऑफ साउथ टूवर्ड्स द फेस ऑफ नॉर्थ. दे डोंट हैव एनी बैक फील्ड लाइन्स, दे हैव ओनली फ्रंट फील्ड लाइन्स. इसको कहते हैं यूनिफॉर्म मैग्नेटिक फील्ड, ठीक है. आपको तो ये भी पता होगा आवर अर्थ इज ऑल्सो जनरेट फील्ड लाइन्स, है ना. यस. सो दिस इज अ न्यूट्रल पॉइंट इज वेयर द पॉइंट हैज नो रिजल्टेंट मैग्नेटिक फील्ड स्ट्रेंथ. सो द मैग्नेटिक फील्ड ऑफ अर्थ, दिस इज द मैग्नेटिक फील्ड ऑफ अर्थ, दिस इज द साउथ एंड दिस इज द नॉर्थ. द फील्ड इज कमिंग एंड गोइंग इनसाइड टू द साउथ. ओके. Plotting the magnetic field line. This will be your homework task, Ayan. After the class, you have to grab your A4 paper. You have to draw this is a bar magnet, and you have to draw the field lines as well. Like you have to draw, you can draw this complete, this one, okay, and mention everything. You have to mention everything. Got it? Because we don't have any bar magnet and we don't have a compass, so that's why we can sketch a random picture, okay. And after doing this, Gigi, no, like this one, you have to make a dots, join the lines, and you have to draw the arrows as well. Then you have to mention which is north side, which is south side. You have to mention these are the magnetic fields coming from and where they are going to, okay. And I hope you get all the idea of the basic concept of magnetism, is it? Do you have any question, Ayan, in today's lecture? Okay, when we understood everything in the lecture, what we call that day? What we call that day? So far, so good, because we understood every single, yes, because we understood every single topic, we understood every single information and detailing and question, queries, and everything is solved in that lecture. Is it? Yes, very good.